Good morning to everyone. I am Dr. A. Kalpana, Associate Professor of Chemistry, PG and Research Department of Chemistry, Sri Sharda College for Women. In this video, now let us see about Pinacole-Pinacolone rearrangement. What is Pinacole-Pinacolone rearrangement? 1,2-diols, which is also called as pinacole, in presence of sulfuric acid or phosphoric acid, undergo rearrangement and forms a ketone, which is also called as pinacolone. This rearrangement is called as Pinacole-Pinacolone rearrangement. That is, 1,2-diols will get converted to ketone in presence of acids. Dehydration reaction will take place. It is an intramolecular rearrangement reaction and it is a dehydration reaction. There is a removal of water molecule will take place. It is a unimolecular reaction. Formation of carbonium ion is a rate determining step. And stability of the carbonium ion is a product deciding factor. And migrating aptitude of the group plays important role here. The migrating group must be trans to the leaving group. The group which is trans to the leaving group will get migrated. In this example, we can see diols, which is also called as a pinacole, in presence of acid undergoes dehydration reaction to form a pinacolone, which is a ketone. And if we consider this is the leaving group, if we consider this OH as the leaving group, the group which is trans to the leaving group will get migrated. So this is a migrating group. Here there is no problem because the carbon possess similar groups, that is methyl. Therefore, the group which is trans to the leaving group will get migrated. Therefore, this methyl will get migrated and this OH is the leaving group. And after that, this H plus will get removed and we get a ketone as a product which is called as pinacolone. This is another example. It is a symmetrical 1,2 diols and as called as pinacoles. In presence of H plus, it undergoes dehydration reaction, that is removal of water molecule, and forms a ketone. If we consider this OH as the leaving group, then this group, phenyl group, which is trans to the leaving group, will get migrated here and this H plus will get removed and there will be a formation of ketone. So this OH is the leaving group and this phenyl is a migrating group and this H plus will get removed. This OH and H will leave as an H2O. Dehydration reaction, there is a formation of ketone here. And coming to the another diol, this is also 1,2 diols, which is also commonly called as pinacole. And here, this is also a symmetrical diol, but this carbon possesses two different groups and this carbon also possesses two different groups. Any one of the OH may get leave. Let us consider this OH is leaving now. So let us consider this OH as a leaving group. And the group which is trans to the OH will get migrated. There are two options here. One is phenyl group and one is para-anisile group, which will get migrate. The para-anisile group is having more migrating aptitude when compared to phenyl group. Therefore, this group will get migrated to this carbon. There is a competition between phenyl group and this group, whereas this group will get migrated because it is having an electron releasing group, electron releasing substituent in phenyl ring. Therefore, this group will get migrated and there will be a formation of product. This H plus will get removed. Therefore, dehydration takes place and there will be a formation of ketone, which is also called as pinacolone. Coming to the mechanism consists of 4 steps. First one is the protonation. Second one is the formation of most stable carbonium ion. Third one, depending upon the migrating aptitude, the group which is trans to the leaving group will get migrated. That is 1,2 shift will occur. And the last step is the removal of proton and formation of product. Let us see this mechanism in detail. Now let us take diol, which is a symmetrical diol. Both OH are similar. Both the carbon are having similar substituents. Let us consider this OH as a leaving group now. So let us consider this OH as the leaving group now. First step is the protonation. H plus will come and attach to this oxygen and protonation occurs and there is a formation of H2O. Second step is the removal of this H2O. The O will take this bonding electrons and remove as H2O and there is a formation of carbonium ion. So there is a formation of carbonium ion. Carbonium ion is formed. Next step is the group which is trans to the leaving group. Which is the group which is trans to the leaving group is this methyl. This methyl is a trans to the leaving group. Therefore, this methyl is called as migrating group. This methyl is called as migrating group. This is the leaving group. The group which is trans to the leaving group is a migrating group. Therefore, this methyl will get migrated along with its bonding electron to this carbon. Therefore, this carbon will have positive charge now. This step is called as 1,2 methyl shift because the methyl from carbon 1 will get migrated to the neighbor carbon 2. Therefore, it is called as 1,2 methyl shift. Then, this H will remove as H plus, giving back this electron, bonding electrons here. Therefore, there will be a formation of ketone, which is also called as Pinacole. Therefore, this rearrangement is called as Pinacole-Pinacolone rearrangement. Once again, let us go through this mechanism. First step is the protonation. H plus will attack the leaving group. There will be a formation of OH2 plus. Second step is a dehydration reaction will take place and there is a formation of carbonium ion. This H2O will get removed and there is a formation of positive charge in the carbon. Next step is the group which is trans to the leaving group will get migrated from carbon 1 to the neighboring carbon 2. Therefore, it is called as 1,2 shift. Since methyl group is getting migrated, it is called as 1,2 methyl shift. The last step is the removal of H plus and formation of product. This H will get removed and there is a formation of ketone. Coming to this example, it is easy. Just we can see both the OH will can get removed. Therefore, they are called as leaving group. Now, let us consider this OH as a leaving group. Now, let us consider this OH as a leaving group. This OH will get removed. Sorry. Now, let us consider this OH as a leaving group. After the removal of OH, this carbon will have a positive charge. And the group which is trans to the leaving group. Now let us consider this OH as a leaving group. And this is the migrating group. Trans to the leaving group is the migrating group. After the removal of this OH, this carbon will have a positive charge. Therefore, this phenyl group will get migrated here. And the last step is the removal of H plus. OH and H will get removed as H2O and there is a formation of ketone. And this substrate will undergo the same reaction slowly and this substrate will undergo the reaction fastly. And coming to this example, it is a symmetrical diol. This is a 6-membered ring and this is also a 6-membered ring. It is an interesting one. Now let us consider this OH as a leaving group. After the removal of this OH, there is a formation of carbonium ion here. The group which is trans to the leaving group or the bond which is trans to the leaving group is this bond, carbon-carbon bond. This bond is a trans to the leaving group. This bond will get migrated here. See here, this bond, this 1,2 carbon-carbon bond, no? This bond will get migrated to this carbonium ion. That is called as 1,2 shift. After the migration, the ring get expanded. 6-membered ring will now get expanded to 7-membered ring. After this step, there occurs the removal of H plus and formation of ketone. So this is the product. It is an example for ring expansion reaction. And it is an application of Pinacole-Pinacolone. Now let us consider an unsymmetrical diol. Here, see here, this is a 6-membered ring and this is a 5-membered ring. We are having OH in both the carbon. There are two possibilities. First, if this OH is removed, or if this OH is a leaving group, means what will happen? The group which is the bond which is trans to the OH group will get migrated. Then the 5-membered ring will get converted to 6-membered ring and this H will get removed. This H will get removed as H plus. So removal of water molecule will occur there. Dehydration reaction. This OH, this H plus will get removed. This bond will get migrate. 1,2 carbon bond will get shifted here. This 5-membered ring will get converted to 6 member. The another possibility is, if this OH is removed, if this is the leaving group, means the bond which is trans to this bond, trans to this OH, this bond will get migrated here, migrated to this carbon. So 6 membered ring will get converted to 7 membered ring. We can understand now. 6 membered ring will get converted to 7 membered ring, isn't it? 6 membered ring will get converted to 7 membered ring, and there is a formation of ketone here, and there is a double bond. This H will get removed. This with H will get removed, and there is a formation of ketone here, and this product, this is a wrong one. This is a major product. So there are two possible ketone formation, and the conversion of 5 member to 6 membered, that is a major product at 97 degree, and the conversion of 6 member to 7 member, that is a major product formed at 0 degree. So both are the major product, but at different temperature condition we can get the product as a major one. Coming to this example, this is also a symmetrical diol, and after this removal of OH, the bond which is trans to the leaving group, the bond which is trans to the leaving group will get migrated here, will get migrated to this carbon. This OH will get removed, this H will get removed. So therefore 6 membered ring will get converted to 5 membered ring. There is a formation of aldehyde. There is a formation of aldehyde. Here, see, we can see here. If we can, yes, we can see here. There is a formation of aldehyde. And coming to unsymmetrical diols, migrating aptitude plays an important role here. And but the product deciding factor will be the stability of the carbonium ion. This is the order of migrating aptitude. That is, aromatic ring with electron donating groups will have higher migrating aptitude when compared to simple aromatic rings, aromatic substituents or aromatic substituents. And aromatic ring possessing electron withdrawing group will have lesser migrating aptitude when compared to the ring with that possess electron donating groups. Then comes the tertiary, secondary, primary, and coming to hydrogen and methyl, hydrogen will have higher migrating aptitude when compared to methyl. In some books, methyl will have higher migrating aptitude when compared to hydrogen. In some books, they will mention that hydrogen will have higher migrating aptitude when compared to methyl. But the product deciding factor is the stability of the carbonium ion. Coming to this unsymmetrical pinacole, see here the carbon possesses 2 phenyl rings, whereas this carbon possesses 2 methyl groups. And there are 2 OH here, that is 1, 2 diols, and it get converted to ketone. Now let us consider 2 possibilities. If this OH is removed, the formation of carbonium ion here, the carbonium ion formed is this one. Other possibility is, if this OH is removed, this is the carbonium ion formed. And if this OH is removed, this is the carbonium ion formed. Now let us consider 2 carbonium ions. Which is more stable? The second one is more stable because the positive charge is stabilized by 2 phenyl rings. The positive charge is stabilized by 2 phenyl rings. Therefore, this carbonium ion is more stable. Then what will occur? The group which is trans to the migrating group, this methyl will get migrated and this H plus will get removed. This methyl will get migrated, 1, 2 methyl shift, and then this H plus will get removed and there is a formation of ketone. So this is a major product formed. The other possibility is, if this carbonium ion is formed, phenyl group will get migrated here, 1, 2 phenyl shift will occur, and then this H plus will get removed and there is a formation of this pinacolone. But actually this pinacolone is a more stable product. Therefore the In this example, the product deciding factor is the stability of carbonium ion. Here, let us consider the possibility of having hydrogen and methyl. See, in this example, two possibilities. If this OH is removed, then this carbonium ion will form. And if this OH is removed, this carbonium ion is formed. Which is more stable? This one is more stable because the positive charge is stabilized by phenyl ring. The positive charge is stabilized by phenyl ring. There is no such stability here. Therefore, when comparing these two carbonium ion, this carbonium ion is more stable because of resonance effect. Resonance stabilization will be there. Then what will occur? There are two possibilities, hydrogen and methyl, which will get migrate. Hydrogen is having higher migrating aptitude when compared to methyl. Therefore, the hydrogen that is trans to the leaving group will get migrated to this carbon. Then what is the next step? Removal of this H plus. Removal of this H plus and formation of product. So this is a major product formed, and the migrating aptitude also plays significant role here, and stability of the carbonium ion is a major deciding factor, product deciding factor here. Coming to this cyclic diols, cis diol, trans diol. Let us consider cis diol and trans diol in this Pinacole-Pinacolone rearrangement. In cis diol, first step is the protonation. No? So the protonation occur in this OH. Protonation occurs. What is the next step? Removal of H2O. Dehydration is the next step. Then what will occur? The group which is trans to the leaving group. Which is the leaving group? OH. Which is the group trans to the leaving group? Methyl. Therefore, this is the migrating group. So there is no problem. The methyl which is trans to the leaving group will get migrated to this carbon. 1,2 methyl shift, and the next step is the positive charge will be here, and this H will remove as H plus, and there is a formation of ketone. There is no issue. It is a normal Pinacole-Pinacolone rearrangement. There is a formation of ketone here. See, there is a formation of ketone. And coming to trans diol, first step is the protonation. Protonation occurs. And second step is the removal of water molecule. But here the OH is the trans to the leaving group. This is leaving group. No, this is leaving group. The trans to the leaving group is OH, that will not get migrate. Instead, this bond will get migrate. This bond will get migrate. This bond. Which bond? Carbon-carbon bond. This bond itself will get migrate, and there is a formation of another carbonium ion. There is a formation of another carbonium ion, and 6-membered ring will get ring contraction, will undergo ring contraction and forms 5-membered ring. See here. And the next step is the removal of H plus and formation of ketone. Removal of H plus and formation of ketone, that is pinacolone. Here, cis diol will give a normal product, whereas the trans diol will give a ring contracted product, that is 6-membered ring will get converted to 5-membered ring. And if there is no diols, instead there is a beta halohydrins or beta amino alcohols, means the substrates will undergo same type of rearrangement similar to Pinacole-Pinacolone and is called as semi-Pinacolone rearrangement. Instead of 2OH, we will have OH and Br, any halogens. And also instead of 2OH, we will have OH and NH2. OH and NH2. So first the leaving group will be the Br. Br will get removed with the Ag. It will remove as AgBr, silver bromide, and we will get a carbonium ion. And the second step, as usual, there is a migration of 1,2 alkyl shift and formation of another carbonium ion. The last step is removal of H plus and formation of ketone. All other steps are similar only. Here, instead of 2 OH, we get 1 OH and 1 NH2, that is called as beta amino alcohols. In presence of nitrous acid, there occurs nitrogen will get removed, and we will get a carbonium ion as usual, and there occurs as usual 1,2 alkyl shift and reprotonation, removal of H plus, and there is a formation of ketone here. These reactions are called as semi-Pinacolone rearrangement, semi-Pinacole rearrangement. So up to this we have seen what is meant by Pinacole-Pinacolone rearrangement, its mechanism, the role of migrating aptitude and its significance, and the product deciding factor, that is the stability of carbonium ion, and also what is meant by semi-Pinacole rearrangement. Thank you.